On Earth Day, two teenagers from Central Europe introduced a device that uses plasma and light to clean water. But the big question is, can it actually help stop antibiotic resistance?
Today's date is 2025-0529. Let's start at the beginning. Two teenagers, Tomáš Čermák from Czechia and Anna Podmaniska from Slovakia, just won the Earth Prize 2025. That's the global award for environmental innovation, right? Pura isn't just another water filter. They combined cold plasma technology and photocatalysis. These are two methods that until now hadn't really been used together. Tomáš focused on the plasma part, which destroys pollutants and antibiotic-resistant bacteria. Anna's side was the light, or photocatalysis, breaking down chemical contaminants.
Exactly, and traditional filters mostly trap particles. They don't actually break down antibiotics or kill resistant bacteria. Pura does both. Why is that important? Because those pollutants, including antibiotics and resistant bacteria, often slip through current filtration systems and end up in rivers, lakes, and eventually back in our own drinking water.
The problem is huge. The World Health Organization estimates antibiotic resistance could cause 10 million deaths a year by 2050. Most of that resistance spreads through water that's been contaminated by hospitals, farms, and factories. So if you're able to remove antibiotics and resistant bacteria before they leave the wastewater, you're cutting off a major route for resistance to spread.
Their prototypes have already shown they can remove these residues. But let's be realistic. Going from a lab prototype to something that works for a whole city, or even a small village, is a big step. What challenges are they up against?
Quite a few. First, the technical side. Can plasma and light work together efficiently on a large scale and still destroy all those contaminants? Then there's energy use and cost. Purifying water has to be affordable and reliable, especially for the communities that need it most.
And there's also regulation. Water purification devices need to meet strict safety and performance standards, and those rules vary from country to country. That process takes time, and it can be expensive.
They've secured some funding, $12,500 as European winners and even more for the global prize. But manufacturing, distribution, and approval all require much more capital. So what's their next move?
They're growing their team, bringing in more students, and looking for partnerships. The Earth Prize gives them mentorship and resources, not just money. That support could make a real difference as they deal with regulatory and business hurdles.
And there's also the 100-year flag they'll fly at their schools. It's a symbol, but also a challenge. Can this youth-led innovation last a century and set a new standard for water safety?
So what can listeners do to support them? Right now, the best ways are to follow their progress, share their story, or connect them with groups that need clean water solutions. Do you think awards like the Earth Prize actually help inventions like this get to market?
It's not a guarantee, but it's a significant boost. Funding, exposure, and mentorship can help take a prototype into the real world. The bigger question is whether governments and industries will help put this technology where it's most needed.
That's what we'll be watching. To sum up, two teenagers from Central Europe have won a global prize with a device that could help fight antibiotic resistance by cleaning water better than before. They're just at the start, but they have a strong invention, international recognition, and the world's attention.
Thanks for tuning in as we followed Pura's journey from idea to global prize. Keep watching these young innovators. They could reshape how we view water and health.
Thank you for listening. This episode was brought to you by mynews.studio. Try it now for free.